Hello guys, as promised we are here with another video on our channel. It's Math Time Questions and Answers, a channel that gives you insights to problems giving you headache at school. Today's question is talking about given that f of x is equals to 2 on x into x plus 1 into x plus 2. Express f of x in partial fractions. Hence, show that the integral from 2 to 4 of f of x dx is equals to ln 27 on 25. So guys, when we are dealing with partial fractions, we already have a video on partial fractions, and we said that at this for the purpose of this channel we will consider three different types of partial fraction, and when we are considering these types of partial fractions we will consider the nature of the denominator. We said that when the denominator is linear, repeated, or a quadratic, we have the various ways in which the numerator can appear in order for us to express that fraction into partial fraction. In this case, we are concerned with a partial fraction whose a fraction whose denominator is simply what? A linear fraction. So the numerator must be constant or true. If you have not watched the video for partial fraction, please don't forget to check the channel for the video. Okay, in this case we are going to express f of x into partial fraction, and we know that f of x is simply equals to 2 on x into x plus 1 into x plus 2. So we have said that since the denominator is linear, the numerator must be constants or true, and since the denominator has three products, we have three partial fractions, and the numerators all will be constant. So let's assume that the numerators are a, b, and c. Then we are saying that f of x will be equivalent to a fraction of a on x plus b on x plus 1 plus c on x plus 2. So in this case we have three fractions we are adding, so we simply look for what? The LCM of those three fractions, and to look for the LCM we simply multiply the denominators of those fractions to give us x times x plus 1 into x plus 2. So if we have that, then we are going to have the denominator like that. So we now start evaluating. X will go into the denominator, x will cancel x, so we'll be left with what? X plus 1 into x plus 2 times a. So we'll have a into x plus 1 into x plus 2 plus x plus 1 will cancel x plus 1, so we'll be left with x into x plus 2 into b. So we'll have plus b into x plus 2 plus x plus 2 will cancel x plus 2, so we'll have x into x plus 1 times b times c, sorry, so we'll have c into x plus 1. So since the denominator of the fractions on the left and on the right are the same, then we must expect that for these two fractions to be identical, the numerators must be the same. So if the numerators must be the same, then all of these a into x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1 must be equals to 2, which is the fraction on the left hand side. So if this is true, then we are saying that 2 is equals to a into, we simply open up the brackets, right? X times x is x squared, x times 2 is 2x, 1 times x is x plus the other 2x will give us 3x, 1 times 2 is 2, so we'll have x squared plus 2x plus 2. B times x is bx, bx times x is bx squared, which is there x squared, and x times 2 is 2x. X times x is x squared, x times 1 is x times c. So we have that. So if that is identical, then we are saying that if that must be equal, then the corresponding coefficients or the corresponding terms must be equal. So the term in x squared on the right must be equal to the term in x squared on the left, and the term in x on the right must be equal to the terms in x on the left, and the constant terms must be equal as well. So if that's true, then we can go ahead and equate coefficients of the terms. So let's look at the coefficient. How many terms do we have there? We have terms in x squared, terms in x, and constant terms. So let's equate terms in x squared. So if we equate terms in x squared, on the left here with 2, is there any term in x squared? No, so it's 0. On the right we have a is a coefficient of x squared because a multiplies all this, b multiplies all this, c multiplies all this. So we have the coefficient of x squared on the right will be a plus bx squared, so the coefficient there is b, plus cs squared, so the coefficient there is c. So 0 is equal to a plus b plus c, and we call that equation 1. So let's equate the next coefficient, which is the coefficient of x. On the right, what's the coefficient of x? On the left, what's the coefficient of x? That's true, is 0 because there is no x on the left. So on the right, it will be a times 3x, so 3ax, so 3a will be the coefficient of x, so we have 3a there. B times 2x, so 2b will be the coefficient of x in b there, so we have plus 2b, and c times x, so c will be the coefficient of x there plus c, so we'll call that equation 2. Then the last terms we have there is the constant. When we equate constants, on the left, what's the constant? 2. Yeah, that's true. So we have 2 is equals to 2a. In terms of b here, we have no constant. In terms of c here, we have no constant. All of the terms contain x, so there is no constant. So the only constant on the right is 2a, and the only constant on the left is 2. So when we equate constants, we'll have 2 is equals to 2a. So if we divide all through by 2, we are going to have a equals to 1. So if we take this value of a equals to 1 and we substitute into equation 1 and equation 2, we are going to end up with new equations like this. So let's substitute into equation 1. We are going to have 0 equals to a. Instead of a, we have 1 plus b plus c. This implies that if we take 1 to the other side, its sign changes from positive 1 to negative. So we have minus 1 is equals to b plus c. And if we also substitute a equals to 1 in equation 2, we are going to have 0 is equals to 3 into 1 plus 2b plus c. 3 times 1 is 3, and if we take 3 to the other side of the equation, its sign changes from positive 3 to negative 3. So we are going to have minus 3 is equals to 2b plus c. So we have those two new equations, therefore we can solve them simultaneously. So those are the two equations we have. So in this case, what can we do? We see that the coefficient of c in this equation is equal to the coefficient of c in this equation. So we can eliminate c by subtracting those two equations. So let's subtract and see. So when we subtract these two equations, we are going to have minus 1 minus 3. So minus 3 will become positive. So we'll have minus 1 plus 3, and minus 1 plus 3 is 2. And b minus 2b is minus b. So we'll have that. So this implies that what we are looking for b, we divide both sides by minus 1. So to eliminate this b here. So in that case, we'll have b equals to minus 2. When we take this value of b equals to -2 and we substitute in any of these two equations, we are going to have the value of c. So let's substitute into this first equation. We are going to have -1 equals to b plus c. So instead of b, we should have -2b because we know the value of b. So let's substitute it there. We are going to have -1 equals to -2 plus c. When we take -2 to the other side, its sign changes to positive. So we are going to have -1 plus 2 equals to c. When we add these two values of -1 and 2, we are going to have 1. So the value of c is 1. We now substitute these values of a, b, and c into these fractions, three fractions that we have there, and then we'll call these fractions the partial fraction of f of x. So we are going to have f of x equals to 1 on x plus -2 on x plus 1 plus 1 on x plus 2. So when we do this, we are going to bring this minus down here to simplify it. So we are going to have f of x in partial fraction now will be 1 on x minus 2 on x plus 1 plus 1 on x plus 2. And that's how we resolve a fraction with linear denominator into partial fraction. The last part of this question is that we should show that the integral of f of x dx is equals to ln 27 on 25. So it is very important to resolve this fraction into partial fraction because it becomes so cumbersome for us to integrate this type of fraction. So we need to resolve it into partial fraction. Now that we have this fraction into its partial form, we can therefore use this partial form to evaluate the integral from 2 to 4. So in that case, we are going to have, that's what we are going to show. So we are going to have the integral of f of x will be the integral of the partial fraction from 2 to 4. So for us to integrate 1 over x is the same as ln x. For us to integrate 1 over x plus 1 is the same as ln x plus 1, because all of these denominators, if we integrate them, if we differentiate them, we are going to have a constant 1. So to integrate them, we are going to have the ln of the denominator because they are linear. But if they were a quadratic or any other function apart from linear, then it will not just be ln x. We'll talk more on this when we deal with integration proper. So in this case, let's integrate and see how it goes. Okay, so if we integrate all of this, we are going to have ln x minus 2, because minus 2 is a constant, minus 2 ln x plus 1 plus ln x plus 2, and the integrals are from 2 to 4. So this integral, these limits of the integral from 2 to 4 are simply means that we should substitute the upper limits in this integrated form, and then we subtract the lower limits from this upper limit. What do we mean? So anywhere we see x, we'll put 4 minus, we'll go into this integrated form of the equation. Anywhere we see x, we put 2. So this will give us ln 4 minus 2 into 4 plus 1 plus 4 plus 2 minus the lower limits of the integral, ln 2 minus 2 into x plus 1, we have 2 plus 1 plus ln x plus 2, instead of x we have 2 plus 2. So we have ln 4 minus that. So we are going to add, we are going to have 4 plus 1, which is 5, 4 plus 2 6, 2 plus 1 3, 2 plus 2 4. So we are going to have ln 4 minus 2 ln 5, 4 plus 1 plus ln 6, 4 plus 2, ln 2 minus 2 ln 3, 3 is 2 plus 1 plus ln 4 is 2 plus 2 here. So if we have that, we know the law of logarithm says that if we are adding logarithms with the same basis, we multiply the powers, and lines are simply logarithms with a base of e, and we call them natural logs. So any log with a base e is expressed as line. So all these logarithms have the same basis, which are base e. So if we are multiplying these logarithms, we simply do what? If we are adding the logarithms, we simply multiply them. So in this case, and if we are subtracting, we divide them. So in this case, at this moment, I will first of all express this one and transform it back to ln 5 power 2, because we said that what if a logarithm is raised to a power to another power, we bring the first power in front. That's what was done here. So we have 2 ln 5. So I can take 2 to the top of 5 to be 5 power 2, and 5 power 2 will be 25. Same for 2 ln 3, it will be ln 3 power 2, and ln 3 power 2 is 3 times 3, which is 9. Then we can manipulate. Since we are adding ln 4 plus ln 6, we can multiply them. We are adding ln 2 plus ln 4, we can also multiply them because of that law of logarithm. So we are going to have ln 4 minus ln 5 squared plus ln 6 minus ln 4 minus ln 3 squared plus ln 4. So let's do the multiplication. 4 times 6 will give us ln 24 minus 5 squared is ln 25. In this other bracket here, we are going to have ln 2 times ln 4, which will give us 2 times 4 ln 8. Ln 3 power 2 will be ln 9, 3 times 3. Now we can open up all of these brackets. So we are going to have ln 24 minus ln 25. If this bracket is being opened, the negative sign is going to affect ln 8 and minus ln 9. So it will change the sign of minus ln 9 to positive ln 9, because minus times minus will give us positive. So we are going to end up with ln 24 minus ln 25 minus ln 8 plus ln 9. Now we are adding ln 24 plus ln 9, and we are subtracting ln minus ln 25 minus ln 8. So we'll multiply these two. So we have ln 24 times ln 9 and minus, you can factor out this minus here, so it will be minus ln 25 plus ln 8. So we can multiply these two and then we totally divide them. So we are going to have ln 24 times 9 minus ln 25 times 8. If we multiply them, we are going to have ln 216 minus ln 200. Now that we are subtracting, we can divide the logarithms from the law of logarithm. So we are going to have ln 216 divided by ln 200 to give us that. So if we have this, what can go? We can see that 8 can go into 200 and 216. So if 8 goes into 200, it will give us 25, and 8 will go into 216 and it will give us 27. Therefore, we can see that if we integrate f of x from 2 to 4 dx, we can get ln 27 on 25. So we say that what? The equation has been gotten as wanted. So guys, that's how we handle problems like this. Don't forget to comment, share my videos, and subscribe to my channel. Don't also forget to leave a comment on the comment section with a question or a problem you want us to make a video on. So stay with me and remain blessed. Bye bye.